Soohoo, this is my Unit 10 video, and so we're going to start off by showing you as to how you can actually make your own license plate. So pretty much in a license plate, it's a number followed by 3 letters and then 3 more numbers, okay? And of course you have your tags, like what month it expires, and then yeah. Okay, so pretty much how it works is you get to choose between 0 to 9, okay? So those are the numbers you get to choose between, and you get a total of 10 numbers to choose from, and you have to pick 4. Okay, so then for the letters, you have 26 letters to choose from, and you have to pick 3. So pretty much, what you're going to be doing is you're going to be doing 10 because of the number. Those are the number of numbers that you actually have to choose from. So it's going to be 10 times 26 times 26 times 26 times 10 times 10 times 10. Okay, and that will get you 175,760,000 ways to choose a license plate. Okay, Mr. Soohoo, now this is permutations versus combinations. So the way permutations works is the order is very important, okay? And over here, combinations, the order doesn't really matter, okay? For example, if you're shopping at Macy's and want to buy a suit, there are 15 kinds of suits for sale. Find the number of ways to buy 5 suits from the store. Okay, so pretty much you would end up with 15 factorial over 15 minus 5 equals 15 factorial over 10 factorial equals 360,360 ways to buy a suit. Okay, now for combinations, for the example, it is you have 30 In-N-Out burgers, but you can only eat 5 at a time. How many combinations can you eat at a time? And then we move down to our problem. It would be 30 factorial over 5 factorial times 30 minus 5 equals 30 factorial over 5 factorial times 25 factorial. You get 142,506 combinations. Now I'm going to show you probability with, of course, your favorite cards, gambling. Yay! Okay, so 2 cards are drawn at random from a deck without replacement. Find the probability that 2 cards are face card and an ace. So pretty much the way that this works is there are 12 face cards within the deck. There are 52 cards from the deck. Okay, like it says right here, face 12. Okay, got it. And then there are 4 ace cards within the deck. Now, if a card were to be drawn at random, you would pretty much take a card out, which would turn it into 51. So now let's say you're trying to draw an ace. Okay, like it says right here, 2 cards are drawn at random. Okay, so pretty much it would turn into 4 over 51. Now you would multiply these two and it would equal 48 over 2,652. Now you divide 48 by 2,652 and you'll come out with your answer of 1.8%. Okay, that would be the probability of actually choosing the 2 face cards and an ace. Now this is how I'm going to show you the complement. Okay, so the basketball team of your school has a 35% chance of winning the playoffs in their division. The basketball team of your cousin's school has 60% chance of winning the playoffs in a different division. Assume the chance of each team winning is independent. What is the probability of neither team winning? So pretty much you would do is you would multiply both teams winning, so pretty much you would equal a 21% chance. Now we're not trying to find what the outcome of them winning. We're trying to find of them neither team winning. So pretty much it would be the complement. So it would be like over here, it would both teams added up, and it would equals 1 minus 21%, which is they have of them both winning, equals 0.79 equals 79%. Okay, but not least, a card is drawn from a deck of 52 cards and is replaced. And then a second card is drawn. What is the probability that the first card is a queen and the second is a diamond? Okay, so pretty much there are 4 queens within the deck, okay, and there are 13 diamonds within the deck. Now if you were to choose a card and you were to put it back, it would be 13 over 52, and then since you have 4 queens within the deck, it would be 4 over 52. Now you multiply them together, it would equal 52 over 2,704, and when you do the math, it would equal 1.9% of actually pulling a queen and the second is a diamond. Okay, so that's the probability. High school students were asked if they like to watch horror films, and response and gender were recorded in the table below. To find the number of those who like horror films, you pretty much add up the column, and then pretty much since 45 students like horror films, you would divide it by those surveyed, which would be 100. It would equal 0.45. It would equal 45%. Given of a certain column, pretty much what you would do is, for this one, it would say those who like horror films, given it's a male. So pretty much what you would do is you would look at this column right here. There's a total of 40 males that were surveyed. 18 like horror films. So pretty much you would take the number of those surveyed that are male, and you would and pretty much that would be the bottom. So pretty much those who like horror films and those surveyed. So pretty much it would be 18 over 40. You divide 18 by 40, it would equal 40, or it would equal 0.45, equals 45%. So at the end of our videos, we wanted us to talk about exactly what our purpose is and what makes us happy. So pretty much, since I'm only 18, I actually kind of haven't found my purpose yet. As I'm going along in life, I'm kind of slowly starting to find it. But yeah, I'm currently not there yet. But what makes me happy? Pretty much my family, my friends, those fun days at school. I would say money, but it's not really the money. It's what money can actually, those moments that money is involved, but it's not the actual money. It's the moments, pretty much. Like, going out with friends. Yes, you do need money to actually, or yes, you actually do need money to do some things. But it's not spending the money or having the money. It's creating the moments that that actually matter and that hopefully will stick with you for the rest of your life. So yeah, that's pretty much what I believe makes me happy. It's those moments with friends, family, whoever, and just the happy times. So yeah.